Hello, and welcome to BUSI 2305, home of business statistics. Yes, with your hostess and the mostess, Professor Naragon. How y'all doing? We're using a brand new video software here, so hopefully everything goes well. So, starting off, Chapter 1. Simple chapter. It's all about the introduction of statistics. So we're going to basically develop your knowledge of basic statistical techniques and methods and how to apply them in business and personal intelligence. That will help you make decisions. Pretty much as simple as we're here to make sure with the proper numbers, how likely will we make a profit? How likely it will succeed, and other little items that will go in with statistics. So we will deal with a lot of technical terms and a lot of math. This is a math-heavy course that we're going to deal with, but it's okay. Take a deep breath as we head into the first part. So, starting off, we're always going to go through the learning objectives of what we're going to learn in each of these chapters. And yes, I'm using the PowerPoint. Later, we'll try other methods of doing presentations and so forth. But first, we're going to explain why knowledge of statistics is important. We're going to define statistics and provide an example of how statistics is applied. We're going to differentiate between descriptive and inferential statistics, classify variables as qualitative or quantitative, and discrete or continuous. We're going to distinguish between normal, ordinal, interval, and ratio levels of measurement. Those are always fun and so confusing. We're also going to do list the values associated with the practice of statistics. All right? Sounds like a lot, but it's okay. We got this. Okay? Each chapter is going to have quite a few learning objectives that we're going to go through. No problem. So, why study the statistics? I mean, simple as this, data is always collected everywhere and requires statistical knowledge to make the information useful. I like how they have bullet points that make simple sense right there, right? It is true, data is always being collected. And you're getting collected on right now. Your statistics are always being collected, and people are trying to predict the outcomes of decisions. Every aspect of business has statistics to it, to the way that you like to shop, to how many people use these items. This one looks like it has a picture of pretty much apps, but this is how much data is generated every minute. And you can nearly see that every place that you go, every website, there's a lot of data that's always being taken in and understand. I mean, just look at YouTube. There's over 4 million videos being watched. Probably right this second, because that's every minute. This is 2018. Managed with the pandemic. Could we predict that we did see a growth in views by YouTube? We probably saw a decrease in certain other areas. I mean, that's true. Amazon probably shipped a whole lot more packages. Netflix probably had more subscribers. Let's see, what else do we have here? Uber probably did not do as many trips as it probably would have. But again, we keep popping up the ideas. So statistics is used to make valid comparisons. We like to do that. If you've ever been in one of our accounting classes, you notice that we always compare businesses a lot with financial data. Same thing with statistics. Statistics knowledge is useful. Yeah, I think I've touched base on that. So, simple. Again, no matter what your career is, you're going to have statistical data. Then we get to bullet points. What is meant by statistics? Well, the definition to statistics in itself is the science of collecting, organizing, presenting, analyzing, and interpreting the data to assist in making more effective decisions. This is so true. This is why I like being an accounting professor, because as accountants, we do the same thing pretty much. That's why stats is pretty much easier for us. It's just diving more into the numbers. And again, they give this like fun example. We always love examples. Where it has the inflation rate for the calendar year was 0.7%, which we know it's a lot higher now, but by applying statistics, we could compare this year's inflation rate to past observations of inflation. Is it higher? Is it lower? Or about the same? Is there a trend or an increase or decrease in inflation? Is there a relationship between interest rate and government bonds? All these are questions that we could answer by knowing statistics. Right now, we do see a trend that's increasing inflation. Hopefully, in the coming years, we may see a decrease, but we usually do see an increase. And we may actually do have a relationship between interest rates and government bonds. Seems about right. But we're going to keep looking at this data. A lot of people analyze. It's actually pretty fun. So, types of data that we're going to experience. Since this is a short slide, we're going to just go ahead and run through all the learning objectives. Usually when it's a longer PowerPoint, I will break it up. But since we're only going 20 slides, we're good. So types of statistics. First one is descriptive. What is descriptive? Well, it has two types, basically. Descriptive and inferential. We're dealing with descriptive, of course. Descriptive statistics can be used to organize data in meaningful forms. And really, we look at the type of question that is asked of us to define the descriptive. So, unorganized data is of little value as it is. But descriptive statistics can be used to summarize that data and provide information that is easy to understand. This is really a big thing that we need to know, because not everybody can understand the technical terms. So we try to break it down to make it very simple, where somebody just looking at it can understand the meaningfulness of the information that is provided. So, with that, we're going to be looking at more descriptive data in chapters 2 and 4. While chapter 3, which is going to come up later in this unit, discusses statistical measures to summarize the characteristics of distribution. So we want to keep an eye on those. Again, we're just doing overall here. So you can, again, summarize all this information And we have the good old definition of descriptive statistics, methods of organizing, summarizing, and presenting data in an informative way. And here's our example. There are a total of 46,837 miles of interstate highways. In the U.S., the interstate system represents 1% of the nation's roads, but carries more than 20% of the traffic. Texas has the most interstate highways, and Alaska doesn't have any. I'm actually surprised that's not Alaska and Hawaii, but again, we kept it very simple. I can see the numbers. I know exactly right here which state has the most, how much traffic actually flows on the interstates, which 20%. But it's only 1%. Wow. So, again, very descriptive, but very simple. So the other type of statistics that we'll have, inferential, which is going to be a little bit of the opposite. This is more of a sample size. So we use it to estimate properties of a population. So it's limited on the data that we actually have, usually limited sets. We typically do not use this as a practical study on the entire population. Sometimes it's very difficult to get that big of a sample size. That's why it stays a little bit limited in the way it goes. We can do it. The census is probably one of the biggest ones that you can have with this data. Also, sometimes they do it with taxes, as the example is shown if you're probably reading the slide already. But we typically end up using surveys. A lot of times surveys. In fact, you've taken courses here at Sanjak, you've already received the survey for to tell how well did you enjoy the class you were in. Those surveys is a bit of inferential data that we use as professors and administrators to better the class and to see how overall everybody is. You always get surveys. They're fun. So, we look at certain characteristics under consideration in this data. And it's also end up being widely used, besides business, in agriculture, politics, and government. There's always going to be samples. If you ever see an election, that's a sample size. It's not the entire population. It's just a sample somewhere. Again, inferential data. So, for the example, this says in 2015, seems so long ago, a sample of U.S. Internal Revenue Service tax preparation volunteers were tested with 3 standard tax returns. The sample indicate that tax returns were completed with a 49% accuracy rate. In other words, there were errors on about half of the returns. Wow, that seems so true. As a tax accountant, that seems so true. Well, errors do happen. But again, they used a sample. They only used a sample of volunteers, only 3 tax returns, and 49% of them actually had an accuracy. So, tells us we're probably going to need to train these people a little bit better, or make taxes less complicated. Either way, win-win. Let's go with that. So here we go. A little bit of description of inferential. Yes, in a world where we learn about stats, we gotta know how to make a sample size. So when we talk about population, This is the entire set of individuals or objects of interest, or the measurements obtained from all individuals or objects of interest. Wow. They could not make that definition any more wordy there. So basically all it is our main set. Every possibility that we could have. So everybody, basically, if we were looking at all 20 through 35-year-olds that like to watch action shows, that's the population size. Now, of course, we probably won't be able to survey all 20 to 30-year-olds, so we're going to take what is called a sample. And the definition for this is a portion or part of the population of interest. And that's where we pick certain individuals. Is it going to always be correct? No. But will it be fun? It depends on the way you want to go. So, that's the definition of population and sample. A lot of times people trying to intermingle those words. Don't do that. Always look at sample size. How does that compare to the vast world? Now, again, this is all estimate. It is not perfect. Estimations are never perfect, so we never take them completely as an absolute. So now we're going to look at some variables. And there are two basic types. I like how they stay with two. But there is two basic variables. There's the quantitative variable, which is basically non-numeric. These are usually what we're going to see as informational, but still not really having any numbers in it. It's usually an object or individual is observed and recorded as a non-numerical characteristic or attribute. So the examples, they gave us gender, state of birth, eye color. We can look at other things like race, since they're staying with person, what vehicle they drive. You can have anything that's really not numerical. So, when we work on these quantitative variables, we simply count the number of observations for each category. Then the percentage for each category can be determined. Because again, we like numbers as statisticians. But, again, some things are not that way, so we gotta basically see what's going on. So, we're often going to always summarize these in charts or bar graphs. Now, since we're dealing with non-numeric in the first one, well, of course, the other part, quantitative, again, having this kind of quantity in its name, is of course the variables that are reported numerically. And they give the examples like the balance in your checking account, the life of a car battery, the number of people employed by a company. Of course, if we're going with physical characteristics again, your height. Your height's a number. Again, your age. Those are quantitative. Anything that we can actually still report as numeric. And again, we can still use charts and bar graphs. I mean, any one that we can actually put in those visual forms. But we want to make sure that you do know the difference between these two variables. And you're like going, yes, I know we need to know because we're going to get tested on it. Yeah, you will. It's a class. It's a course. Of course you're going to get tested on it. So, again, we have the quantitative can be discrete or continuous. When we look at this, why do we call these two different ways? Well, discrete variables are typically the result of counting, which values have gaps between the values. So, they give the example, the number of bedrooms in the house could be 1, 2, 3, 4, etc. The number of students in a statistics course, 326, 421, etc. Wow, that's a lot of students in one statistics course. They probably should have put statistic courses. Just imagine putting 421 students in one room. It ain't gonna happen, especially not today. Well, we look at continuous. Continuous variables are usually the results of measuring something. Can assume any value within a specific range. So again, discrete's going to have the gaps. They're not going to have, like with bedrooms, 1.5, 2.3, 2.2. You don't hear those. You usually hear 1, 2, 3, or 4. Very rarely you hear half. That's usually with bathrooms, but not typically with bedrooms. But with continuous, we're looking at specific ranges. So duration of flights from Orlando to San Diego, 5.25 hours. Grade point average, 3.258. They are going to have very specific ranges. So it can be any of those variables. Not really gaps in between. So this is going to lead us with this types of variable summary. Nice little graphic that we actually do have. So we're going to start with types of variables. Again, qualitative, quantitative. Qualitative, right down straight to the bottom with basically, again, words that we can have to convert into numbers. So brand of PCs, marital status, hair color, more examples that we can always have. While quantitative, again, since it's numeric, deals with two others. We look at discrete, like children in a family. Again, you can't have half of a child. Strokes on a golf hole. There is no percentage or decimal places. TV sets own. Unless you're Willy Wonka, you will not have half of a TV. And of course, continuous, again, specific ranges, amount of income tax paid, weight of a student, and I like the yearly rainfall in Tampa, Florida. I don't know why they choose Tampa, Florida. Probably because that's where the current reigning Super Bowl champions are. Alright. So there's our little graphic. Again, always look at these graphics. I will always encourage you to use the smart book or read the textbook. It's going to help out a lot. So levels of measurement. Now, these are going to be interesting as we go to keep basically them separate. But there are 4 types. There's the nominal, ordinal, interval, and ratio. And you're going to probably hear me mispronounce the O one quite a bit. It's a bunch of order right there. So, the level of measurement determines the type of analysis that can be performed. And they are in certain levels. Nominal is the lowest level of the measurement. It basically is data recorded at the nominal level of measurement is represented as labels or names. They have no order. They're more chaotic, if you want to look at it that way too. They can only be classified and counted. That's the key. Can only be classified and counted. Alright? So, this does not permit any mathematical operations that has any valid interpretation, even if numbers are assigned to the labels or names. So again, no orders really here. So examples are classifying M&M's candies by color, identify students at a football game by gender. That's a very specific example right there. But classic, if you've ever been in a probability course, you may remember the M&M's. I still remember those, and that was decades ago. But I always liked doing the M&M candies by color. In fact, if this was in person, we probably would have done that. Free M&Ms for all. So the next level is the ordinal level. And this is where we start ranking a little bit of our measurement data. So they are starting to be known, but not to the magnitude of differences between groups. Okay. So they're going to have more of still qualitative variables. Our attributes is either ranked or rated on a relative scale, such as rating a professor as superior, good, average, poor, or inferior. RateMyProfessor.com. There we go. Notice there is no way to determine the magnitude of the difference between superior and good or any other ranking. It's a good example there. So, again, we're going to record data at a ranking base. So this is where ordinal comes, kind of gets us the sense of order. But we have not really defined too much of a meaningful of the attributes in themselves. So they're only ranked and counted. Okay, so we had nominal, which is classified and counted. We only classify them as a certain thing. Ordinal is ranked and counted. So examples, again, the list of top 10 states for best business climate, student ratings of professors, which we went over. Basically, going to watching WatchMojo.com on YouTube, where they do one of their rankings. Again, it's all about ranking system. If you like sports, ESPN, when they do their power rankings, again, stuff like that. So the next level of measurement, number 3, is interval level. Now you're going to start seeing, feels like almost a shift happening. So these now, the data has all the characteristics of ordinary level data, plus the differences between the values are now meaningful. There is no natural 0 point. That's also a very big key. Make sure you have that. So when we look at this, the basic definition in itself is for data recorded at the interval level of measurement. The interval or the distance between values is meaningful. The interval level of measurement is based on a scale with a known unit of measurement. So again, now we're heading to more quantitative, where we do have numbers to give us a more meaningful level. They have the temperature scale and dress sizes. So again, when we look at this, especially with temperature, we can be ranked, and the differences between the values is meaningful because, again, we can actually say 80 between 60, or 80 and 60. There's a meaningful means on the temperature scale. One's hot, one's cold. Additionally, a 0 does not represent the absence of the condition. So there is no natural 0 point. We have 0 degrees, which just means very cold. Below freezing there. So that's really what we're looking at. Where it doesn't remove the meaningfulness if it hits 0. It just still has a attribute to it. So again, kind of like ordinarial, except now we have the meaningful basis to it. So let's get to the highest level, and then we'll show you a graph again. So the highest level of measurement is the ratio level. This is one that we typically use a lot in math, is basically ratios 3 to 1, those stuff. The data that has all the characteristics of the last, basically 3, but mostly the interval scale and ratios between numbers are meaningful. Again, gotta be meaningful. The 0 point represents the absence of the characteristic. So, again, in the interval, there is no natural 0 point. It still has meaningful. Here, there is no, there is a 0 point, but it loses the absence of the characteristic. So basic definition again, data recorded at the ratio level of measurement are based on a scale with a known unit of measurement and a meaningful interpretation of 0 on the scale. So they like to give you examples of wages, changes in stock prices, and height. So let's look at this. Again, we have basically shifted from qualitative, non-numerical, mostly non-numerical items, to really shifted really big into quantitative, where ratio is pretty much all quantitative. It's almost all at the ratio level. The 0 point in ratios between the two numbers, again, is meaningful at this time. So when we look at money as an example, if you have no money, you have $0. Means you lost the characteristic of money. You have nothing. And a wage of $50 per hour is basically, can be interpreted as twice as much as a wage of $25 per hour. Wow. So basically, for the person that's working 25 per hour, whoever's making 50, you're making 2 times as much, or a 2 to 1 ratio. So again, we put meaningful into it because we definitely know you're making more money. But if you don't have any money, you're 0, you lost the characteristic of money. You don't have it. So again, we give 0 a meaningful response where there is absence of that characteristic that we're looking at. And we can also basically convert everything into numbers. So how does this look like in their little chart? Here's our chart. Again, going from the lowest on the left to the highest on the right, we again have nominal, ordinal, interval, and ratio, which we're all going to get into a lot more in this course. Again, big keys, nominal, data may only be classified. So again, jersey numbers of football players, make of car. Again, a lot of qualitative. Ordinarial, again, data is ranked. Your ranking class, team standings in the Southeastern Conference. We definitely know where this book was made. We have interval, again, the next level, where we add meaningful differences between the values, temperature and dress size. And then ratio puts that meaningful 0 point and ratios between values. Again, 0 point shows that we lost the characteristics. So profit, fuel efficiency, distance to class. That's a good one. So again, that's just a basic summary. We're again going to discuss this data as we progress more closer to the end of the course. Looks like we're going to be looking at more methods of how to use these, mostly around chapter 9 to 14, 15, and 16. So if this is a business course, you must deal with ethics. So ethics and statistics. Simple enough. Again, I cannot teach you ethics. I can teach you what happens when you do certain things, but we're all already set in our ways. So, I want to tell you basically this: practicing statistics with integrity and honesty when collecting, organize, summary, analyze, and interpret numerical information. Again, you don't want to be, falsely producing information to make it seem like you're right. You have to be independent. Okay? You gotta maintain that independency and principled point of view when analyzing and reporting findings and results. You cannot change the numbers. Don't change the numbers, because they do end up getting redone quite a bit. If you're reporting something that's bad, when somebody else takes the same numbers and reports good, there's questions. So, question reports that are based on data that does not fairly represent the population, you end up questioning that, does not include all relevant statistics, and introduces bias in an attempt to mislead or misrepresent. Again, we have to be independent. The numbers are absolute in the way that they are, but they can't always be swayed. That's why we got to make sure we do have a sample size that is represented fairly before we produce, because it can lead to other items coming out. So basic business analytics. The best and fun software that we typically use is going to be Excel. Here it is. So, business analytics is used to process and analyze data and information to support a story or narrative of a company. We use computer software to summarize, organize, analyze, and present the findings of statistical analysis is essential. It is. It's a whole lot easier. Again, best software, if you ever going to learn for business, is going to be Excel. Learn it. Learn all these fun little shortcuts like pivot tables and other items, and you're going to be golden. Okay? So, again, we're going to use all these analytics basically to help answer questions like what makes us profitable, or how will our customers respond to a change in marketing, which is always good. The example that they have, actually this nice little picture, refers to sales information from the Applewood Auto Group, a multi-location car sales and service company. Minitab will also be used to illustrate applications. I actually did like Minitab. We'll get into any kind of software as we can. It's not a guarantee we're going to get into all statistical software, but I will help you out as we go. Now let's see what else is with this Power Slides. We have practice problems. So how will you do? So I will always tell you on these, pause the video during practice problems so that, one, you can try to answer it before I give you the answer. So pause it as soon as the question pops up, unless you want to hear me read it, and then pause it before I reveal the answer. So let's try. Again, chapter 1. We're going to work with it. So, what is the level of measurement for each of the following variables? A, student IQ ratings. B, distance student traveled to class. C, the jersey numbers of a sorority soccer team. D, a student's state of birth. E, a student's academic class. This is freshman, sophomore, junior, or senior. F, the number of hours students study per week. Again, pause if you want to answer these before going into. Alright, so starting off first, A, student IQ ratings. This is going to be interval. Okay, again, we have kind of a ranking system similar to ordinal, but we have meaningful numbers to it. And 0 does not reduce the characteristic that we're looking at. Yes, a person can have 0 IQ. It's very unlikely, but it can happen. So, but it still has meaningful information there. Don't lose the characteristic. Okay. B, distance students travel to class is actually ratio. There we do have a 0. That means we lose the characteristic. Because if you have basically 0 distance to travel, there is no distance. And we can actually put that in ratio numbers, and again, more quantitative. C, the jersey number of a sorority soccer team. Again, we should know that seems more qualitative and not really a ranking system in there. So that will be nominal. A student's date of birth. Again, nominal right there. There's no ranking. There's no meaningfulness between the numbers or the items. And again, more qualitative in itself. A student's academic class. Again, we can actually see a ranking system already being put in. So we still don't have a meaningful item. Basically, you don't really see a good number or anything. So, this is more ordinarial. Like I said, I'm going to mispronounce that throughout the whole class. Anyway, last but not least, number of hours students study per week is going to be your ratio. Okay. Again, you can have 0 study hours, which basically loses the characteristic. It's no longer there. That's always going to be the key on that one. Okay? So, question 13. I did question 13. Learning objectives 4 and 5. Actually shows that. This is the last slide that we have for this chapter. Yay, you're like going, yes, the video's over. But, of course, let's do it again. So for each of the following, determine whether the variable is continuous or discrete. Okay? Remember, if it doesn't have gaps, it's continuous. If it has gaps, it is discrete. Quantitative or qualitative. And the level of measurement. Ooh, they hit you with all of them. You're like going, no. It's okay. It's in the homework as well, so. No. So, again, we have salary, gender, sales volume of MP3 players, soft drink preferences, temperature, SAT scores, student rank in class, rating of a finance professor, and number of home video screens. Okay. So pause real quick, see what you can answer, and then here we go. So starting off first with A. Salary. So we'll look at salary in itself is a quantitative number. Again, it is a number in itself. We will probably see it as a ratio in itself, and of course it is continuous, because again you can have multiple different numbers. Gender in itself, gender is a qualitative form. So again, since it's qualitative, it does not have continuous or discrete. only quantitative does. And that's going to be probably running around the nominal level. Okay. Again, if I got qualitative, it's probably going to be closer to nominal than anything else. Sales volume of MP3 players. Okay. Again, we're probably looking at a quantitative item there. Again, we got numbers on themselves. And again, we can actually have it as discrete. There probably will be gaps because again, we cannot have percentage. But since it's dealing with cells, they had to be a little bit more specific. If it's volume on the, basically, this is how many MP3 players we have sold, it will be discrete. But if it's sales in cash money, that is continuous. So that could go either way depending on how they're actually looking at it. Yay on that. Since we're looking at sales volume, we're probably going to be looking at a ratio as well. Again, meaningful at 0. Either way on that one. Soft drink preferences, that's going to be a qualitative. So again, cannot be discrete or continuous. It will probably be set on a ordinary aspect because we are dealing with rankings with preferences. Temperature, we already know that one from prior sides is on interval or a level of measurement, so that would probably put it as quantitative. And continuous as itself as well, because we can have 65.5 degrees, so forth and so on, in a specific range. SAT scores, again, quantitative, we have numbers. Just one. Alright, so SAT scores, again, we're looking at quantitative at a interval level. Again, 0 actually still keeps the characteristics because you can make a 0 score. Again, we have to have it where it completely removes the item we're looking at to be ratio. And this one is actually discrete in the way that it is because there is no percentages, basically decimals. The score is basically straight numbers. Next, G, student ranking class. If you got this one, again, we're looking at a qualitative version of this. Because again, student rank. So again, no discrete, no continuous, because that's only what quantitative. Leisure measurement is, of course, ordinarial. Anytime we're doing rank or preference, which will also mean rating of a financial professor is going to be ordinal in the way it uses. And basically, again, another qualitative notion. And last but not least, number of home video screens. So, number of home video screens can be quantitative information, because again, we're dealing with more numbers base. Since it does have a 0 for meaningful, it will be ratio, because again, if we have 0 home video screens, that means we lose the characteristic of that item. And of course, we're dealing with discrete, because we're not going to have half of a video screen. It's just not going to happen. That's how I like to think. Can you actually have it and be correct on it? Okay, so that's it for Chapter 1. So if you made it this far, yay! What I want to say is congrats of starting this adventure in statistics. We're going to get into more information as we go. You're going to see lots of ways that we calculate statistics in itself in the business world. So not as crazy advanced as an actual statistical course, but it's going to be fun either way. And I look forward to being on this adventure with y'all.